For section 5.4, number 2, given sine A as 5 over 13, A is in the second quadrant. We're going to find cosine of A over 2. For the formula cosine A over 2, it is either positive or negative of square root of 1 plus cosine A, all divided by 2. That means we're going to need cosine of the angle A. Given A in the second quadrant, the x is negative, the y is positive. And by the given information here, we know that sine A is y over r, therefore y equals 5, r equals 13. And in the second quadrant, x can be negative sine that can be computed as negative of the square root of r squared minus y squared, or x equals negative square root of 13 squared minus 5 squared, and we get x as negative 12. Now we get x negative 12, r 13, and y equals 5. And set it aside, the cosine A is from x over r, which is negative 12 over 13. And next we're going to analyze as an angle A. Since A is in the second quadrant, that means A will be between 90 degrees and 180 degrees. Therefore, A over 2, or I have angle A, is between 45 degrees and 90 degrees, or A over 2 will be in the first quadrant. If A over 2 in the first quadrant, that means the sine of A over 2 and cosine of A over 2 will both be positive in sign. That's the analyzing part. Next, we're gonna bring it back into the main piece of the problem. So then the cosine of A over 2 gonna be positive square root of 1 plus cosine A, all divided by 2. And simplify or substitute the number cosine A as negative 12 over 13 added by 1 and all divided by 2. Divided by 2 means multiply by 1 over 2. So I'm going to write it as 1/2 of 1 plus cosine A. So then we have square root of 1/2, multiply the quantity 1. The cosine is negative 12 over 13. That means we're going to get the value 1/2 multiplied by 1 over 13, which is square root of 1 over 26, or you can write it as 1 over square root 26 as a result.